Tomorrow Corporation Tech Demo. Internal programming and debugging tools. All right.
Hello, everybody.
Hi.
My name is Alan Blomquist. I'm
Hello,
the
Alan.
engine and sort of the low-level programmer at indie game developer Tomorrow
Low-level
Corporation.
programmer.
And today I'm going to do a quick demo of some of our internal tools and specifically focus on programming and debugging.
Okay.
We've been developing games and a lot of the tools that we use to make them for over a decade now.
Wow.
And at this point, we're using our own programming language, compiler front end and back end,
Okay,
editor,
bro.
debugger, build
Okay,
system,
bro.
and game engine. I got really interested in working on stuff like this when I read years and years ago. It must have been
Okay. Okay.
a blog post or something about this thing called Goal that they developed at Naughty Dog for some of their PS2 games. And it was like a custom programming toolchain.
Okay.
And I remember reading about that and just thinking that this is obviously like the coolest thing that I've ever heard of.
Yeah.
It didn't seem like something that you could even do. So
Graph
that
idle,
really
seconds
made an impression
active,
on me and
runtime.
kind of showed me my own lack of imagination at the time. But fast forward to 4 or 5 years ago now, and I got a chance to work on something like that for our own company. And it's kind of become like a passion project for me, so I'm excited to show off some of the cool things that I think we've been able to come up with.
Okay.
For this demo, I'm going to use a port that I made of one of our games' human resource machine that wasn't originally created using these tools, but I wanted to have a real finished
Human
game to use here
resource
and not just like
machine. Now, let's see if, like, the tech is great and all, but did it also translate, like, I love tech. However, what I love more than tech and programming is games. It's on Steam, sells for 15 USD, came out in 2015 by the Tomorrow Corporation, and it's actually quite successful. 2,800 reviews. Yeah, not bad. Definitely not a flop. That's a lot of sales, yeah. And considering they have made their own programming language for this. Now you can see that these are 2D sprites in a probably 2D image, right? But let's see if they have more than one game. So before that game, they had Little Inferno. Oh, wow. Little Inferno on Steam is the same type of game, which makes sense, right? It takes time to make your own programming language and then your own tools. So what probably happened was they found a way to do a game and then they kept improving upon that process. That's what it feels like. Unless the third game is completely different. Let's see. So we have Little Inferno, which was the first, then Human Resource, which looks very similar to that, right? And then we have 7 billion humans, which is very positive. And the latest one of them came out 2018, actually. And it looks awfully similar to the first two games. I wonder if they're working on a new game now.
Also, this game happens to be a game about programming, but this demo is about our development environment in general, and so it would apply equally well to any of our games. I'm going to start with just sort of the basic version of what a lot of the rest of this stuff is going to be based on. This is the only non-code part of the demo where I'm going to show off my art skills and do a simple hot load of a data asset. So if I bring up a texture,
I mean, that's what I'm doing too, but okay.
From the game here, and I make an edit and save it, then we can see that it shows up here in the game without having to stop and restart it. So that's a nice feature to have. But now we're going to build off that idea and see what else we can do.
Okay, what can you do? Because this is the most basic hot reloading that you can have in a game. I have that. Almost everyone that is making a game, even the big game engines, kinda have this. But oftentimes you have to still reload something. But yeah, that's the most basic reloading feature.
I'll open up our code editor here and we'll see if we can't do something a little more interesting.
Ooh, I mean, if they can work like that, that's crazy. But I need colors. Okay.
This is the code that's drawing these green boxes over on the left side here. And since we hot loaded data, it's only fair that we hot load code. So if I make an edit here, we can see that that gets hot loaded too. Our compiler is incremental and it builds native code pretty fast, so we can compile on every keystroke. And there's almost no delay between me typing into the editor and the changes showing up in the game.
That's actually crazy.
It's kind of ridiculous.
Like for me, it is a couple of seconds. That's already fast, but they have it much faster. That is really crazy. This is, wow.
13,000 line source file.
Guys, have you seen that? Should I, like, let me rewind something. I want you guys to listen to something, okay? Listen to this. Watch. You ready?
And the changes showing up in the game, even in this kind of ridiculous 13,000 line source file.
13,000 line source file. Things get bad after 14,000. Okay, bro. Sure.
If I navigate over to the code that's drawing the floor here with these blue boxes, we can see some debugging features. If I set a breakpoint at the top of this function, you can see that the scene is kind of partially drawn in right now.
That's crazy.
And then as I step through here, I can see the different things that I'm drawing showing up on the screen as I go.
Holy shit, that's insane.
Since this is our own debugger talking to our own game engine, we can kind of arrange to keep the screen alive while you step through code, sort of like a graphics debugger. And that can come in handy sometimes when you're trying to figure out where some stray little thing on the screen is coming from. Another thing I can do while I'm stepping through my code here is actually do a step backwards. I can do backwards versions of the usual step in, step over, step out, and I can run backwards to my breakpoint, and I can also run backwards to hardware data breakpoint.
This is insane.
And being able to debug backwards from an assert or a crash, especially with a data breakpoint, is insanely helpful in being able to figure out and fix bugs. And one of the keys to make...
Just one thing. This is crazy, right? This is crazy. This undoubtedly is like a next level. However, at least in my experience, these bugs where you don't know what's happening are very rare. And at least in my experience of like 3 years of learning C++ now and making a game. It is definitely faster, but how much time do you save? Maybe you do save a lot of time. Like if you make some crazy applications.
Making this as practically useful as possible, as that this isn't a special mode that I launched the game into in order to do this kind of debugging. This is just the way it works all the time.
This is
so
crazy.
You always have this option available while you're working.
Okay. But how fast does your game run though? With
so I'll switch over to the game window now, and we can look at our in-game profiler. By default, the instrumentation for the profiler doesn't get compiled in, but when I click Enable here, we do a full recompile of the game code, and now we're getting our call graph instrumentation.
What is this?
And it looks like there are some spikes happening on some of these frames, so I'll pause this data collection so we can take a closer look. If I look at the frame that got expensive here, there's this one function taking up most of the time.
Yeah, spike 11.
And normally in a profiler, you can click on the name of the function and go see the source code, and I can do that here. But since we can debug backwards, another thing that I can do is click on this timestamp up here. And when I do that, I'm taken to the actual invocation of this function on this frame.
That's crazy.
I can debug and see that the reason that this took so long this time is that I got an unlucky random number. Now, obviously, this is a contrived example, and this isn't a silver bullet for every possible kind of performance issue, but it's a cool additional tool, and it can be really useful for certain kinds of situations.
Yeah, you can basically debug. You can debug long functions, and you know where to look. Why does this function in particular take long?
Once I resume this and get rid of this bad code here, then the profile looks good.
Okay, how many FPS?
Compile out the instrumentation code.
Or do they have vertical sync?
So the profiler can tag function activations with these timestamps for debugging, but that's also something that you can do yourself in code. For example, a lot of the time if you create something at one point in a program and it needs to be cleaned up later, you tag it with some kind of debug information so you know where it came from. So memory allocations are a thing like that, where you normally tag those with like a file name and a line number, or if you're lucky you can tag them with a call stack, and it makes it easier to debug memory leaks and stuff like that. So here in our programming language we have something like an intrinsic that when it gets evaluated at runtime, it gives you the current execution timestamp, and you can use that to tag stuff with instead. So I'll break into the game here, and I'm going to look at the data for the boxes that I put on the conveyor belt to solve this level.
Level.vm.outputs.
So I can see that there are 3 of them here, and if I look at the middle one I threw on, here's the timestamp I associated with it, and then I can use that to go back and look at the point in time when that box was actually thrown onto the conveyor.
Okay.
And if I undo that, I can go back and look at a different one and see what was going on when I threw that one on. So that's an example of the kind of thing that I might tag in this sort of game, but in other games you might tag the creation of all your bad guys, or remember the last time the player got hit, or track the history of every door that you walk through, or whatever else you can think of. These timestamps are super cheap to generate, and they're only 64 bits, so you can use them to tag pretty much everything with what effectively is the entire state of the program. And then you can go back later and inspect anything you
so, okay, but you need to jump to the timestamp, okay.
need to if you want to find out where something came from, or why it didn't get cleaned up, or whatever you want to know. So finally, now we're going to turn the determinism
All of
off
this is crazy, but okay, yeah.
all the way up to 11. So when I come in here and bring up our developer console in the game, we have a scrubber and some playback controls down here. And this timeline has everything that I just did during this demo, and I can use it to go back and sort of inspect any part of it that I'm interested in.
That's insane.
And this isn't like a video that we're looking at. This is the actual simulation and rendering of the game.
Time travel
on demand.
This has to be fake. You know what I find crazy? With all of this high tech, like, I don't want to like demean them or anything for making a 2D game, but why do they not make a 3D game? Shouldn't they be able to make like the craziest 3D game with this? Right? Because they have all of these tools. 3D is too hard. They should have enough money. You can't do this with games with a lot of state.
This all still works even though I did stuff during
Mr. Almeida,
the demo,
thank you very
like
much for gifting us up
fully
to
recompile the code for the profiler. I edited the code for these boxes and I changed this texture, but I can still scrub back and forth through all those different changes. I specifically wanted to try not to have one-way streets in this functionality, so using one feature.
He's storing the whole game
state,
I think. Yeah, it would be cool to that he explains how he's doing this. Yeah,
a different one later on. So if I go back to before I changed the code for these boxes, if I come in here and I debug this now, I can see that this is the original version of the code before I changed it. And that's because
TCAP, he's not only storing the game's state, he's also storing the code, the programming language. Game state on code change. So basically he's probably not even storing the game state. He's storing something else. I don't know what exactly he's storing.
Is aware of this whole system, and it always lets me work with the state of the code as it was at the time that I'm looking at. I could also go back and profile code after the fact. If I'm playing along and I see a weird hitch or something like that, I don't have to start thinking about how to reproduce it. I can just...
Wait a minute. I'm interested in this. You guys ready? How they interact is fun. Unfortunately, not $15, especially considering the limited assortment and short runtime. I'm trying to look for a bug. I don't get the fun of burning things, watch things burn, plus the game will give you a key item halfway through the game, which is you must not burn it down, otherwise it's a bad end. So it's a big no. Really enjoyed the base game over the years, but since downloading the DLC, it crashes every 2 to 10 minutes. Very disappointing. Wait, so it still crashes. It's neat, but there's one thing that really pulls this game down for me. I don't enjoy the delivery time as a mechanic, and you can get stuck waiting for a while if you mess up. There's a way to speed up, but it's a limited resource. The mechanic only serves. Okay, so working on the games. Locked achievements behind DLC. Okay, let's try to look at human resource. This is when they learned, right? TLDR, don't read this review and just buy it. TIS 100 instead. It's infinitely superior in every way possible, completely blows this game out of the water. TLDR, reason only 3% of players have the green optimization award achievement. Isn't it because the game is hard, but because the game becomes unplayable in the end? It's a good programming puzzle game that is badly let down by some trivial, but intensely irritating flaws. With all of these debugging tools, what I would assume is that they have like basically almost no bugs. I'm a professional software engineer. I like programming games. Human resource was okay. I like the graphics. The puzzles are pretty simple for the most part, which with the exception of the side branches and puzzle blah 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 blah. Brutal challenge, okay. I'm hesitant to leave a negative review, but I feel like because of the overwhelming positivity the game has in its reviews, prompts the developers for taking low-level programming concepts and turning them into an interactive gaming experience. This game has immense potential, but ended up leaving me disappointed. Past level 20, the game becomes dull. I love the animation style and the game concept, but the puzzles became cumbersome. Okay, so mostly I'm begging to realize that assembly programming type games aren't my thing. As you progress, only reward more complex puzzles. Yeah, really want to comment. Yeah, so it looks like none of them really has negative reviews in terms of performance or bugs, which is what I was looking for.
Just go back and see what it was. And the point of all this isn't that I'm just dying to go back and debug my stale code. The point is that the system as a whole is a coherent set of features that all work together. So if you've worked with other determinism-based replay systems, one of the issues that they tend to have is that they feel really fragile, and you have to have constant vigilance that you don't do something that's going to break the determinism. But in our case, since we've created every level of this stack to support this, we can super efficiently offload.
You know what I would like to see? He went to the spot, right, in, let's say this is a video, in the video where he changed something, right? He went to that spot where originally he changed something. What if he goes now into the code and changes something? Does this entire line get cut off, or is the frame just added at the end with the change? What happens? What happens then? Because like this is what I would do. It splits the reality, right? Yeah, it basically creates a black hole into a different universe, and then that change is there, right? It's a fork. The PC will probably explode. What did I mention? Yeah, see, that's the real question here, you know, what we have to answer. Okay, what if you change the code in a different way? Maybe he goes into
determinism stuff to the development environment, and essentially you can just write whatever code you want without having to spend any time thinking about whether or not you're breaking something. The other cool thing about this is that we save a session file with this timeline every single time you run the game. And since this whole thing is integrated with our version control, the amount of data we actually need to save to be able to replay a timeline stably at any point into the future is really small. And it's not just programmers who are generating these session files, it's everybody on the team, and the files are portable. So if you're a designer working on a level and something isn't working quite right when you try it in the game, or you just randomly saw something weird happen and you want somebody to look into it, you can send your session to anyone else and they can play it back live and debug it.
That's really
cool. This is all integrated with our build system so that it all just works even if you had local changes.
It just works, guys, okay? The different universe, it just works. Good exploring the 3D side of Godot this morning. Oh, wow, that's cool, bro.
Created the session, and the person playing it back is on a different revision and source control, and they have their own local changes. The system can get all the data it needs to play back the session, and it doesn't touch any of my actual local files in the process, so there isn't any risk of me losing work if something went wrong.
Wait, so I think I understand how it works. This replay system is basically... No, I don't understand. He doesn't go into it.
I have a session here that I have prepared ahead of time, and we can imagine that somebody sent this to me to look at because their game crashed.
5,000 frames.
So I'll load this up.
He loads this up, yeah.
And I'll run it to the end, and sure enough, they got an access violation here. And you can see that the boss from Human Resource Machine lives on our panic screen, and he's not happy with me right now. So one thing I can do is just sort of go back through this session and look at what happened. So it looks like somebody played through the level once. They went back and sort of optimized their solution, played through it again, and then got this crash. So if I click on the top of the call stack here, I'm taken into the code editor, and if I got an access violation on this line, that probably means that this pointer is null. And I know that this is a parameter to this function, so I'll do a reverse step out of the function, and here I am back before I called into it, and here we're passing the null pointer
Playtime
in.
target.
And I can see that that pointer is supposed to get set up in this if block, depending on if you're in normal play mode or playing on the phone. And if I look at the current value of this play mode variable, the debug...
Guys, look at this. A local scope. Just wanted to point that out because I use local scopes a lot. And people ask me, why do you do that? Well, to organize code, bro. Helps.
is saying that the value it has is not actually a valid member of the enumeration.
There's another local scope right here with a comment. Tick portrait phone cam movement. Just saying. I didn't copy them. I didn't even know they existed, bitch.
Here, you might recognize that that's the floating point number 1. So at this point you're thinking, this looks like a memory stomp, and I better cancel my plans because who knows how long it's going to take me to figure this out. But what I can do here is bring this play mode variable into my watch window, and I can set a data breakpoint on it. And now when I run backwards, I'm going to find the most recent
where
write
the data
that
changes
into that memory.
Yeah. So basically he's changing some other data around, and then at some point in some other piece of code, this piece of code actually changes that data, and then the data breakpoint will be hit.
That was right here. I'm assigning the value 1.0 to something, so that makes sense. And if I go back a couple more, it looks like the index...
Oh, look at this. This is pointer arithmetic. Slider history index. Slider history buffer plus. Crazy.
Using to write into this buffer started at 15. It incremented to 16 compared to the capacity, which is also 16. So it
basically
should have wrapped around here, but it didn't.
Yeah.
And it looks like this is the bug here. This greater than should have been a greater than or equal to. So obviously, again, this was a contrived example, but this isn't a totally unheard of kind of bug, unfortunately. And you can imagine that if I were attacking this with printfs or something instead, I might be in for kind of a long night. Luckily, though, most bugs aren't even that complicated. They're just like run-of-the-mill logic errors in gameplay
most
code
of them are.
So being able to debug those with this kind of system makes it super easy.
Yeah, of course. Yeah.
So that brings me to the end of the demo. Check out the links in the description for more great
He should probably tell how long this took to create, because all of this stuff is fancy, but how long do you spend on this? How long was the time until they thought, well, maybe we should do that? And how long did it take them to develop to get to this point? He says at the very beginning that they've been in the gaming industry for about more than a decade now, right? And you can see their very first game is 2012. So if we take that, that's more than 12 years. Anyways, still a really cool video, I have to say. Unfortunately, he doesn't go into too much of the technical details, which I guess I can understand. It's more like a tech demo, right? What they do. They just explain, or he just explains what they do, not how they do it. And I think if you check out the other videos, yeah, it doesn't look like they are interested in posting more, or let's not say posting more, but posting like tutorials on how they did it.